Max has an amazing experience in using functional programming languages in a variety of settings, in finance, in startup world, and we're going to talk about basically all kind of languages he used and all kinds of scenarios. So Max, maybe we can start by telling us a little bit, like your few previous years experience, and like what kind of cool languages and technologies you got to play with.
So my first exposure to functional programming it didn't hold. It was, taking the computer science classes in university where you learn how to play with linked lists and maps and you never touch it again. So that didn't hold. The second exposure was at a really amazing company called Jane Street Capital. I was a trader out of Tokyo, but because even though I was a trader, I had some technical experience, so I got heavily involved in the systems and quant systems and development, backtesting, and that was all OCaml. So, of the three other people in the office, no one knew anything, so I was completely self-taught and started reading up and realized that you can actually do productive stuff in these functional programming languages. I was kind of shocked. All I thought of OCaml was, implementing a DFA and NFA and, all the theoretical fun stuff in university. But, Jane Street was making millions and millions of dollars off a technology stack that's nothing but OCaml and Excel spreadsheets with VBA. So obviously, OCaml was really doing the heavy lifting there. So I had a great experience at Jane Street, and then I had a kind of meandering career through finance where I finally left to launch my own startup in Singapore. It was a loyalty card startup. It wasn't an exciting business, but the technology we built, I'm very proud of. What we did is we wanted to have like those punch cards, buy 10 sandwiches, get one free. But rather than QR codes or some kind of weird technology, our app would actually scan a receipt and send the receipt image to the server. We would parse it, pull it apart, perform structural analysis on the receipt image, and figure out what the customer bought, how much they spent, and assign them their points accordingly. Or we could also tell the merchant what people were buying. We gave them much richer data. The business failed. We did a piss poor job of marketing it. We basically solved a non-existent problem, but we built some really cool technology. So the technology we used, we had a full Haskell stack. The web app side of the application was fully powered by a web framework in Haskell called Yesod, which is, you could describe it as a radically type-safe web application framework. Your HTML templates, all interaction with the database, it's type-checked in a sense that you never really get with conventional frameworks, or even conventional statically typed languages like Java, C#, etc. And then the mobile app was 99% HTML5 and JavaScript generated by this Yesod web app, wrapped in a small PhoneGap layer so we could deliver updates to the client over the air that didn't to go to the App Store. The receipt scanning required some custom C code that we wrote, which we packaged up as a PhoneGap plugin, or Java code on Android. And then we had this full stack, and we're really proud of it, and even though we didn't do a great job on the business, the technology was pretty cool.
That sounds really great. I think there is a lot of interesting entry points here. So let me start with OCaml. I think Yaron Minsky has several talks available on the web, and a lot of folks in FP have seen them, where he talks about the sweet spot which OCaml occupies, that it's functional enough, but it's not Husky enough to be sort of productive, but not overly esoteric. It's really surprising, right, and interesting how it can power Jane Street. So they are, as I understand, high frequency traders, and OCaml, as we know, is not fully concurrent, right? So I wonder, and a lot of people hold against it, and so I wonder, first of all, how that plays out, and how it enables the company to trade in a very fast fashion without being blocked by concurrency, effectively, which is like the language does not support like full-threaded model.
Yeah. So not sure if I should say this. One of the dirty secrets of OCaml and Jane Street within OCaml is that the way they really squeeze out productivity is essentially by programming imperatively within OCaml. I don't think it should be a dirty secret. I think that is the strength of OCaml, that it lets you get that imperative programming. For instance, really simple example of using maps versus hash tables. So in OCaml, maps are functionally pure, referentially transparent, immutable, data types that when you alter a map, you actually just get a new one.
Correct.
And hash tables are not. They
Yes.
are destructive, non-thread safe. They're actually in-place memory updating. So they're not pure and beautiful
And everybody uses them.
because they're orders of magnitude faster.
Yes.
So for me, I think the sweet spot in OCaml basically comes from the fact that it lets you cheat, in a sense, similar to Scala, whereas Haskell does not. In the long run, I actually think Haskell's a better solution. Jane Street actually has one saying that, which is that programmer time is more expensive than CPU time, and this is for a high-frequency trading shop, you know, where like clock cycles have actually, you know, calculable costs in terms of how, you know, how many cycles something takes to calculate will actually cost you trades. And even there, they felt that the CPU time was, you know, not as expensive as developer time. And I think the assurance that Haskell gives you in the long run does save developer time. Having said that, you know, OCaml is a great language, and relative to what 99% of businesses use, which is, you know, C# or Java, OCaml is so much better that's not even, almost not worth talking about relative to C# and Java. So, you know, Jane Street's done a great job of that. You know, on the one hand, I kind of disagree with Ron, and I think a lot of Jane Street's OCaml use is kind of a historical accident. That's kind of what they happen to be using, and it grew up. I think when they started, Haskell was, even though Haskell is an older language, Haskell was more immature at the point that they started using it. Now Haskell's really caught up. I think Haskell's a much better solution. However, Ron is, you know, absolutely brilliant. He's done amazing things at Jane Street. So, you know.
So, but
Your
in
mind
terms
is
of
bigger.
concurrence, I'm still curious because that's
Okay.
kind of a lot of people. I know you can implement several processes, and
Which is essentially what they
which
do.
is and I mean that's the only choice left to you. But would you say that mentally, folks would like to use other models? I mean, like, would you see internal debate or desire to use this for financial applications, or is it just not how people think? I mean, maybe it's just easier to think in terms of loosely coupled processes which communicate sometimes through shared memory somehow, and maybe that's the way to write this kind of applications.
So it depends on your problem scope. One thing about the problem scope that Jane Street deals with is, and I should say I'm a couple years out of Jane Street, so information is a little dated, but for the most part, the problems they deal with are highly partitionable. The computations involved in pricing one particular security with the arguments of the user are not super difficult. What's difficult is doing it for the universe of securities, you know, real time. However, it's pretty easy to just separate your universe and partition them and, you know, run multiple processes. That isn't necessarily the case in a lot of other applications, you know, especially if you get into any kind of like social networking or graph theory stuff. It's much harder to partition that. So that's where something like a Haskell or, you know, hopefully one day Rust will be stronger relative to OCaml. You know, if your space is partitionable, you know, you can kind of get away with OCaml, but then you're not really getting that much relative to conventional imperative programming languages.
Yes, I see. So another interesting thing is I remember that during the financial crisis of 2008, I think Jane Street did well, and the reason, you know, they like I heard one of the reasons is, I mean, it's a high frequency trader, and they basically, you know, trade very fast. So would you say that OCaml was one of the reasons for the success? You know, I mean, is this kind of paid off? I mean, is this really a good sort of poster child functional programming in industry that it will be fast enough? And super fast.
I wish I could say that functional programming was the last stand defense we had against global economic collapse. Jane Street did well during the financial collapse for essentially two reasons, one of which I can talk about, one of which I can't. And the one I can talk about is that the business they were doing, which is high frequency equity trading and Delta One arbitrage, basically wasn't strongly affected by the crisis.
Right.
You know, I mean, it's that is probably one of the larger reasons why they did well.
Okay, so FP certainly didn't hurt.
No, functional programming did not cause the global financial crisis.
And it did not hurt.
And I will say, because actually the co-founder of my current company, where we are actually now getting into some solutions that we're looking at Scala or Haskell, launched the derivative CDO trading desk at one of the larger banks. So, you know, my partner actually did cause the global financial crisis. So, you know, it's something we talk about somewhat regularly. So if you want to come work for a really cool startup where you can, you know, see the inside story of what happened, Doc Bunch would love to talk to you.
All right. and we'll get to that in a moment. And now onto the Yesod. I mean, that's I think I find it very fascinating. I think I met Max at the Scala meetup, and that was one of the things which really piqued my interest. That somebody really doing a startup on Yesod, not just talking about it. And in fact, I mean, I've seen an O'Reilly book coming out on Yesod, and I thought that the very fact that O'Reilly putting out the book like this is already a sign of courage. And somebody is basically endeavoring to do a framework for startups and hoping somebody will use it. And I mean, now I see that it actually there are several. So I mean, can you tell us how this came about? And basically, in separate from business trajectory, what was it like in the startup life cycle to from inception to design the system, to build it, to invent, to maintain it? What's your experience of Yesod?
So starting with Yesod, me and my partner in the other startup, he came from the Ruby world. So it probably did slow us down a little bit relative to something we could have thrown together overnight in Ruby on Rails. But it imposed on us a discipline to do things right the first way. We didn't have this huge technical debt build up. Mm-hmm. And so after maybe like a little bit of a slowdown, say total 2 to 3 man months in terms of the prototype, we actually found that we were much more productive. The code was much safer. Mm-hmm. So we loved it. Now, when we started, Yesod was just about taking over 1.0. So it was, actually, I'm sorry, no. When we launched, Yesod was taking over 1.0. When we started, Yesod was at 0.4. Mm-hmm. So we were actually pretty intimately involved in the development process of Yesod. I was a young founder. Well, not young. I was inexperienced. I don't want to say young. It's not really true. I was inexperienced, and we kind of took a risk on a very new framework. Framework ended up being successful. People use it. It has traction. But there were a lot of times that we had to make changes because of that. I remember one version transition went from 0.5 to 0.6, I think, and changed one of the underlying string management libraries. Literally, just to upgrade to the new version of Yesod, we had to change 1,200 distinct points in our code base, which, I don't think our code base was much more than 20,000 lines. Mm-hmm. So that was a little frustrating, but, a lot of Vim grep. And,
is it the artifact of Haskell having separate several string classes and basically the way
so this is kind of a unique thing to Haskell. However, after changing the code in 1,200 places somewhat manually, we didn't have a single regression bug. Mm-hmm. Nothing went wrong. No test broke. It wasn't even like we compiled, we ran the test failed, tried it. It was once it compiled, mm-hmm. It worked.
It worked, yes.
And that was like one of those like aha moments when I thought, this is pretty amazing. And that was a good thing. With two of us, it was hard to. It ended up being a relatively complex application, mm-hmm. and just to have this very well-defined behavior, to understand every action that we were doing in the system, mm-hmm. Really helped a lot. So, all the time that we might have spent on like automated testing, we were able to skip a lot of that in a sense and still have an incredibly robust, solid product.
So that's, I think sort of there is like a honeymoon phase when you write a code base and it's new and it's fresh, and then you finally in production, and then you have real users, and then you have completely different set of expectations, and if you want to make deadlines, and often people cut corners and then just say, I want it to work, I don't care how, but we should support this feature, or this bug should go away, and so forth. So what was it like in that phase?
Well, the first thing I would say is that one of the advantages of having really good technology and a really bad business model is you tend not to have a lot of users. And your kind of unit user per unit technology is very low. So that problem was kind of solvable. But actually, one thing that I really liked about it was exactly what you said. There is that temptation to cut corners. You just throw this feature in. Haskell, and especially Yesod, with the discipline that it would force on you, it kind of prevented that. So it might slow you down a bit, but as I said, it really prevented this large accumulation of technical debt. Mm-hmm. Mm-hmm. So, it's one of those things that in the moment can feel frustrating, but at the end of the day, you're glad you did it. Mm-hmm.
So in terms of monadic I/O, right? I think that's the barrier to entry for most beginners. And web is nothing like I/O, right? The users are doing something, and then you output the results back at them, right? So So I mean, I looked at ASOT a little bit, so but I don't have a deep feeling what it means in terms of the whole application. So can you talk to it a bit? Like, does this flow resemble Ruby on Rails, or is it actually making it different enough?
So, I mean, when you talk about Monadic, you bring up a larger class of issues with functional programming in the large, and especially Haskell, which is taking concepts that aren't that difficult and making them as esoteric and unapproachable as possible. I firmly believe that if Haskell basically forked itself and renamed monads to contexts and a couple other word substitutions, it would have 5 times the adoption. The way so my partner in this company didn't really do much Haskell beforehand. He did a tiny little bit. And the way I trained him was I didn't go through the derivation of the state monad. We didn't go through, working out all the monadic rules and verifying this and the theory. We just said, I need to do this. How do I do this given this, monads? What is the behavior? And that's fine. And it's not, when you think about it that way and you separate out the lingo, you separate out the category theory, it's not that difficult. There's slight things can be kind of like an inversion of control, and you might have to think about your entry points a little differently. But if you think about Ruby on Rails or any web framework, there's so much kind of inversion of control anyway.
Yes.
You're not writing a writing a program that kind of steps through a series of commands. You're essentially building functions that some library is going to call.
You're plugging in a big flow, and the flow is defined as a convention for you. So very similar.
So I actually think in the context of a web application, it almost makes more sense. However, in general, I think that Monadic IO and all those issues are something where the terminology and the aesthetics of it, for lack of a better term, make it seem much more unapproachable than it actually is.
Yeah, it makes sense. Actually, I mean, the way you described it, how you trained your co-founder, actually sounds almost like the way I picked pieces of it which I needed, right? Because I learned Haskell and in the context of actual practical application, analyzing an actual live Twitter graph. So I wanted to compare Haskell and Clojure and Scala and OCaml. So I just needed to do things. So basically, that's exactly the way I approached it. And I'm curious, if you have a good way to train people, you should definitely formalize it and make a little course, right? Because that's I think how software engineers learn. They learn in a series of patterns, and the simplest is a textual pattern, and you see hello world. So if you learn, if you have a good way to present these patterns, how to do things with something other people call monads, but they're real in contexts, and that actually would be a great.
Well, you're the one with the education company.
Yeah, so we'll definitely should talk about this.
I almost feel like it's almost too intrinsically obvious, and the community's just doing something wrong. If I wanted to teach someone how to write Java, and I wanted to explain how a try-catch statement works, I'm not going to get into processor interrupts and stack rewrites and context switches and all that. I'm going to say you write some code, and if it throws an error, then you have to catch it.
That's right.
So it's something that everyone's doing anyway. It's just in Haskell, people say no. Forget that.
Yes.
We're going to do it this way. That has never worked in the history of teaching anything ever.
Yes.
And hope that somehow it's different.
Yes.
It's actually, this brings up an interesting issue within Haskell, which is kind of unique, where you have this really this split in the community where half of the people, I wonder if they've even actually compiled their code, or if they're just worried about compiling their LaTeX and writing papers. You have this academic side, which is purely focused on academic research and all that. And then you have the industrial side, which is different and more than any other language. Yeah, it's more recent. There's this tension. However, it's tension that I think serves the language well. There are downsides to it. For instance, the way most people approach teaching Haskell. However, I think that in the end, this is what makes the language so strong. This is why they were able to implement software transactional memory in a weekend.
Yes.
If you think about all the effort that's gone into that, and for Java, you can because you have no mutability control.
Right.
Or in Haskell, because they kept the purity, because they had this academic ideal of a functional language, they were able to implement it in a weekend.
I wonder, I remember you had this controversy with Michael Snowman by writing the Prelude, and I'm wondering if maybe you can relate this episode, and I wonder if there is any teachable moment there about the Haskell community, or is it shedding any light on how it works?
Now you're getting me in trouble. So, All right, here's the background. The Haskell core library, it's called the core library is called the prelude. It's the implicit import in every function.
Yes.
And prelude has a lot of functions, like to find the head of a list or to find an element in an associative map or associative list, which are unnecessarily non-polymorphic. If you think about, like to see if an element is a member of a map or list, there's no reason that has to be a list. Like, rather than having to import the data.map version of a function and the data.list version and the data.set version, why not just have a polymorphic function? Because there is actually a type class that represents that you can run off of that.
Right.
So we felt it would be more productive, if we had a fully polymorphic prelude, where rather than having to, go through and change your imports and change your functions, you would change the data passed in.
Because the membership is a very basic operation.
Exactly.
I mean, if Clojure does this, why not Haskell?
Exactly. What we did not do is when we released version 0.01 of the library, write strict algebraic laws describing the behavior of each function associated with the library. Now, there were intuitive laws. We know what the member function does, but there's all sorts of corner cases, and certain elements within the community felt that this was a complete affront to the mathematical beauty of Haskell. Now, I think part of the problem is, there are two complaints. One issue was that, the algebraic laws. The other was that it would make compilation errors much harder for especially beginners to understand, which is absolutely true. There's nothing we can say about that. We weren't proposing this as a replacement to the current thing. We just said, for power users, we think this might be more productive.
Right.
We picked up a little bit of flaming from the community, more than I thought, actually. So I think one of the things that we should have done is just make it clear that we weren't trying to replace anything. People are afraid we're going to replace it. Libraries were going to use this prelude and then it'd be incompatible. You'd have this kind of like infection where you couldn't have a library using the classy prelude and then a normal library.
Right.
So I think we should have made it clear that it's not designed for libraries. It's designed for end products. And that we're not trying to replace anything. This is just for power users. So definitely mistakes we could have made. However, I think Michael Snoyman had, he's the developer of Yesod and also Classy Prelude. And even though I love Yesod, Yesod is very dependent on little DSLs. So rather than programmatically defining your, ORM, your database ORM, or your HTML templates, there'd be like, or your routes even, there'd be a little DSL that you would write them with. So it ended up being much more concise, clear. It was still statically type checked, beautiful. Some people felt that was not the Haskell way. It was non-Pythonic, but whatever. It was not Haskell-ish. I disagree. I think DSLs are a huge strength of functional programming languages. People accuse them of trying to change Haskell, which I thought was... It struck me as one of those comments that people would make when they haven't actually used the framework. They just read blog posts about it. Because when you use it, you find that it's much easier to define your routes the way, with using this DSL than, the algebra.
This type-safe URLs.
Type-safe URLs are wonderful. I wish I had them now.
Yeah, I mean, it actually strikes me as a great idea. Now any other framework I use should use them, right? I mean,
almost none of them do.
And I think Clojure now has some notion of. I think this will spread through, right? That's the pioneering thing. But what you say about the community division, about the beauty, actually, to me as a software engineer, polymorphic prelude is beautiful, right? Because I don't want to care about multiple membership methods. So I'm really curious. So the fact that somebody would think it not beautiful means they're holding on to this, algebraic properties, which I can't see anything beating compression and minimalism in production, right? So I think that actually probably talks to these two different roots, and I think it's interesting. It's interesting to me. But the fact that they were afraid that it's going to be a replacement means it was close enough to become a replacement if necessary. So I mean, basically, it could only have been that if it were actually a real option, right? And if Prelude is a library in Haskell, right? It means that it can be replaced. The definition of a library is you can take another library. So if Haskell treats it as a library, I think it's up for grabs, to treat it as a library. So I don't see a problem there.
I do just want to make sure that it's clear that even with this tension, the Haskell community is one of the best communities for any language that I've used. Even with this tension, if you ask, and there's a couple of beginner questions that get asked almost daily. The listservs are incredibly helpful. you know, it's rare that you can ask a beginning question and have the father of the language answer it.
Yes.
You know, they're very helpful. The community is great. And, you know, I mean, the academics, if you go along with their assumption that we were trying to replace the default prelude, I could understand their trepidation
Yes.
of having a prelude without algebraic properties.
Yes.
Which were later introduced, and now we have them.
Okay. So do you have it? I mean, can I use it now? I mean, I'm just curious. If I want to Prelude, can I play with
you
this?
could use it when the controversy came out.
Okay.
You know, that's the nice thing about Haskell is you never have to be really afraid of using, you know, pre-release libraries.
Mm-hmm.
You know, the type system saves you in a lot
Right.
of cases there.
Right.
You can use it now. I haven't been that involved with the project lately. I've been involved with this new project.
Is it no package?
I think so. I know it's on GitHub.
Okay,
I mean, that's the biggest problem with Haskell right now is hackage and package management. And
How is that? I'm subscribed to a Twitter stream and I see like it seems like majority of contributions to packages from Michael Neumann, because I see like he's committing all kinds of things all the time, and they're not like they're foundational, like there are strings libraries and HTML libraries and all kind of things, right? So I mean, obviously somebody's committing to it.
So, well, now Michael Neumann is part of FP Complete. FP Complete, so you know they're really getting behind it and doing a lot, and I think they're trying to drag Haskell into being a productive environment.
Mm-hmm. So package is alive and well, right? Like that's the way.
Yeah, no,
to get
it works. I'm just saying, as a package manager, well, not just package, but Cabal and Hackage are one of the sore points in Haskell.
Oh, okay.
Again, not to denigrate the people who've written them, they solve some really hard problems, but you know they've been around for a long time.
So are there some features which are not supported?
You just get like dependency management is probably the big. I mean, they support it and they're actually very strict about it. So if you actually satisfy your dependencies, then fine. But sometimes you get weird cases where the dependency management is a little off. And you know, having said this again, I've been outside of the Haskell community for almost a year, so I don't want to give all the information.
Yeah. Okay. Cool. So sort of kind of going back a bit to your Singapore startup. I mean, it actually is pretty interesting to me that you had a mobile component which you were solving with ESOT. So it's actually sounds like a very appealing feature, and I think that HTML5 and PhoneGap wrapper sounds like the excellent first step. You know, people would use this. So I mean, so you have, you know, under your belt this architecture where you have the ESOT framework, you have the mobile app. I mean, you can almost like next week talk to any VC in San Francisco and offer them a solution, right? Because you know now if you know how to make a startup processing cards and have, you know, a little mobile app. Right. So to me, the beauty of this of the things is abstraction. So you basically have a framework. You know how to serve a mobile app. I mean, what prevents you from basically taking this and making the next startup, you know, in 2 weeks? Or I mean, is this actually a working solution? Is this abstraction enough? That you can basically, because you should probably have user management, right? You have some kind of monitoring. You can run in production. You probably, hopefully, can know like what kind of load you are handling. So I don't know what the ops part of this, right? How can you scale? Maybe we'll talk about this after. But is this an abstraction? Is a Haskell abstraction powerful enough so you can abstract, you know, what is actually the startup doing? Take the most of your code and your mobile app tomorrow and make another startup with that.
So I guess your question is, can you make something like a Heroku or a Parse for startups to run Haskell?
Yes.
And it's something we actually thought about a long time ago. One, I mean, we're getting well away from the technology here, and this is I have to put on my CEO hat and my VC hat. Right now, mobile HTML5 is not cool. I strongly disagree with it. I think the reason is because Facebook app version 4.0 was written pretty poorly in poor HTML5, and then they had a very well-written native app. So everyone said, "Oh, look, the native Facebook app is so much better than the HTML5 one." Whereas I kind of think that it was more like a very well-written native app is better than a poorly written HTML5 app, which no one's going to argue with. However, that's definitely set the tide against mobile HTML5 apps. I haven't seen anything in the Facebook app that seems like it would be impossible to do in HTML5, and the Sentry guys even implemented a good chunk of the functionality in pure HTML5 without a PhoneGap wrapper. Having said that, I have a friend who's on the Facebook mobile team, and he claims that they tried and it was impossible. So I could be wrong. I don't know. I mean, I think mobile HTML5 is still a great solution, and I think most of the stuff that's being done in apps does not need to be done in apps. It's done in apps for reasons like monetization, push notifications, things like that, which you can get with PhoneGap. I don't think there's a huge demand from startups who want to have like a mobile app written, where they can write their backend in Haskell. It seems like a company like Parse, which goes the other way. Parse provides the backend, and you can write the front end. Android or iOS native app has been fantastically successful. So I think technologically you could do it, no problem. You combine it with AWS, or actually we're using Microsoft Azure now. So a little shout out, thank you Microsoft. I never thought I'd say that, but Azure's actually really nice. I just don't see the demand for that.
But I mean, still, in terms of Haskell shell, right? I mean, basically, even if not, as a Heroku-like service, I'm just wondering about the power of abstraction, right? Because you in Haskell, the abstraction is so high, you can basically say, you can abstract the things users are doing without really caring what they are, right? You can have like a startup monad, right? Which is basically mediating between buyers and sellers of X. I mean, like 95% of simple startups are, you find some kind of middleman position. The tourists are visiting your city and you have attractions, or readers are reading news streams and you find a tailored combination of them, right? So basically, you position yourself in the middle of some kind of resources. Resources are customized for users, right? It strikes me as this can be abstracted over properly with tools. So you mastered this. You did all this hard work on of building a startup. I'm just wondering how reusable is it to you? For this kind of, like, if you have to do a consumer-facing startup in the future, would you now dig out your ESO code and would you try to fit it? Do you feel you left it at the quality which is enough?
There's a difference between me digging out my ESO code to use in my next project and packaging that up as a platform that I'm going to sell to other people.
Right.
I would use that for me personally.
Yeah, that's my question.
However, I'm not sure that there's any business in selling it. I don't see where the demand would come from. You don't see startups clamoring to do that. I think if you had, maybe this is what the Meteor guys are actually trying to get to, something like that, but it was actually abstracted away into Node or Ruby or something. You might have more demand. And again, I think Haskell is a better platform. It's just, where's the demand? And, in our current startup, DocMunch.com, I love Haskell and I love Scala. We actually built a prototype in CoffeeScript and Node, and that was just because I had a co-founder who was not super technical, but he actually taught himself a decent amount of programming, got a master's from Stanford. So just so we could, get it out, we did it in Node and CoffeeScript. So we are moving on from that now.
Maybe you could tell us more about DocMunch and what is it doing and what's your current startup experiences? Okay,
so DocMunch is a private data cloud for finance professionals. So if you think about data that people in finance deal with, 90% of the time they're not dealing with what we think of as big data. Small data sets they get from analyst reports, broker reports, hedge fund returns, things like that. The problem with big data, dealing with stock prices, security prices, returns, that's a solved problem in a sense.
Yes.
But there's this other set of small data. Broker sends you a research report with a bunch of mortgage delinquency rates. You want to pull out that table. So what our system does is it lets you extract data from PDFs, Excel files, PowerPoints, store single tables and charts and data points in our cloud. Anytime you upload similarly structured documents, maybe every month you get a report, you upload it once, pull out data once. Next time you upload it, same data is pulled out for you. Store data in the cloud so you can then access it very fast and easily in Excel via an Excel plugin. So our problem is this document structure analysis, detecting what is a table, what is a paragraph, tagging all the data, presenting it, letting users share it, collaborate. So in the typical workflow in a bank where a research analyst might calculate some model figures or numbers, coefficients, and they will generate a spreadsheet that they email to a trader to execute trades on, or email to a client to trade on, we're trying to get into that flow. So rather than emailing a spreadsheet, you put it into DocMunch, and then the traders use it straight in DocMunch.
Okay, so it's basically it's Evernote, but with much deeper financial
Data-centric Evernote.
data-centric. Yeah. So which will actually look inside of the content. So actually, it strikes me as a very interesting application because a lot of these things will be recurrent, right? So your broker report will come regularly.
Exactly.
So you only need to invest once, and at this point, you probably shouldn't shy away from using human intelligence, right? Like if if the user actually will point out what he wants, and you'll assist them, right?
That's exactly what we're doing.
Right. Then basically you can learn what they want, and you mentioned Azure. I sort of am a secret fan of F#, and in that case, I think Microsoft did an excellent job, and I remember F# advancing ahead beyond a camel, and one of the areas is type providers, right? The type provider is basically you can specify the type of an incoming data stream, and essentially you only need to do it once, and then because you can be reading some weird CSV table which maps into your structure type in a certain way. So you basically may specify it once, what the first line is like. And then basically the language will check that the type is a bait, right? So it almost sounds like you will each of your data streams will have a type if it's a recurrent, right? So you can actually say what the type should be like, and then you can actually use type checking to see if that's like. It just strikes me that actually it maps pretty well to a functional model. But I'm curious. Right. Obviously, it's a lot of. It may involve a lot of computational intensive things. So what kind of thinking are you doing in terms of processing? Right. So obviously, Kafka is an excellent choice for front end, and we are using it ourselves. And I think it's a fairly standard model that front end is now done in JavaScript or JavaScript. It's all in the browser. You have rich apps where you can interact with content. It's JavaScript is excellent for this, but if the time comes to analyze it, parse it, do language extraction. There is a lot of libraries done in other languages. So what is your thinking like in that sense?
Yeah, so we're balancing a couple issues there. When we look at the contenders for what we want to base our heavy backend processing, we're looking at Scala, Haskell. Go is up there, even though I'm not a huge fan of the language, but the ecosystem is amazing and the tool chain is great. There's a language coming out of Mozilla called Rust, which I'm actually very excited about. It's not quite ready yet. Rust is if you took C++ and Haskell and they had a child, and the child wasn't a horribly mutated freak, it would look like Rust. Rust is, think of it as like C++, but with controlled, essentially mostly immutable data structures, controlled mutability, high concurrency, very strong static type system. So it's like C++ meets Haskell. It's great. It's just not ready yet. Mozilla's actually writing their next generation rendering engine called Servo in Rust. So I think it's great, and I just wish they were about a year further along. Those guys are doing really incredible things. So so when we're looking at something like Haskell versus Scala versus Go, we're comparing. The obvious things are we're comparing library availability, programmer productivity, but we're also comparing things like recruiting. One thing we learned from Jane Street, and it's been true at my previous startup, is that if you put out a job request for Haskell developers, you will receive between 1% and 5% as many replies as you will receive if you ask for Java or JavaScript developers. However, of the that 1 in 100 guy that replies, you can be almost certain he's a smart guy.
Yes.
There are very few dumbasses replying to Haskell job postings.
Yes.
So you've got an incredible signal to noise ratio, and I think Haskell's on top. And then you've got Scala's up there too, and the problem with Rust is no one's actually heard of it. And then Go is going to be a little lower, and then you get your JavaScript and Python and C# and Ruby's under the table. Sorry, I just can't stand it.
So that's basically a great self-selecting filter for recruiting, right?
Yeah.
So that
that's really one of the unsung features of the functional programming. The other thing I just wanted to say is you mentioned how Microsoft did great things with F#, and one thing that not a lot of people are aware of is that Microsoft is actually developing two functional programming languages. One is F# and the other is Haskell. Most of the work on GHC and the core libraries has come out of MS Research. So, if someone ever says, why are you using, some crazy exotic functional programming language with Haskell, you just say, well, no one ever got fired for choosing Microsoft.
Right, exactly. It's a Microsoft tool.
Yeah,
Yeah,
it's like Visual Basic.
I think it's great that Microsoft actually supports, that, and that's yeah. I mean, I met with the developer division. For Sharp folks. I think it's a lot of smart technology being developed there. Azure actually tried it along with F Sharp because I think F Sharp is an excellent gateway, and they're trying hard to actually make Azure useful from F Sharp. So I mean, for the first time in history, you have a choice.
Yeah. So originally, actually, they wanted F Sharp was going to be Haskell. The problem was they just couldn't get the laziness to work right on the CLR, which is why they ended up going with OCaml, which is even if superficially relatively similar to Haskell, because it doesn't have the laziness by default and some other exotic features like Haskell has. They were able to get it on the CLR much more easily.
Yes. And actually, I mean, that in my mind is a problem with big data, right? Because I try to process Twitter graph with Haskell. Process Twitter graph,
okay.
right? A very huge data set. And essentially what we ended up doing, if I represent my graph as a map, and the map is lazy, it led to all kinds of problems in Haskell. So essentially we had to strictify, I had to go and add banks everywhere, and essentially then I got OCaml. So then basically in some scenarios laziness is not easy to work with. I mean, I'm sure in deep theoretical sense it's always good, but in this practical sense, you have this huge graph and you need to do something with this. You need to serialize it. That was not trivial.
You're preaching to the choir on that one. A conversation I had with Michael Snorman, actually, the SO developer, is that we, in addition to forking Haskell and changing the word monad to context, we felt that a strict by default version of Haskell would essentially solve 99% of the problems people have. And that's almost where I see Rust going, is it's kind of the strict by default version of Haskell. And the reason they have the laziness is, well, in addition to the academic research, that was what they needed to get monadic programming working. Monadic programming cannot work without lazy semantics. So
I think Clojure strikes a good balance, that the sequences are lazy and map is lazy, so that's a very typical beginner problem, right? But because it's in this context and everything derives from sequence, then you have essentially lazy processing of streams for free. You don't need special syntax for that, and most everything else is strict. So I think that maybe that's
it definitely makes Haskell cause a lot of problems, and we had problems with it too. I mean, I've written some trading systems in Haskell, and the laziness killed me. And, I mean, it's makes your code very difficult to debug.
Laziness doesn't somehow sound right for the high frequency trading. So interesting. I mean, I'm actually a bit surprised at your conundrum in terms of libraries, right? Because all kinds of machine learning and especially language processing. I don't see among your choices anything which beats JVM, right? Because there is a lot of libraries for language processing. I would say that if you look at language extraction, the competitors will be Python, which is used by a lot of computational linguists, and so Python and Java, right? You have basically two choices here. So I think Haskell is popular in the theoretical sense. There are some cute libraries. It sounds like something which computational linguists would pick, but it actually, I think, is a bit too much esoteric for some of them, so they actually settle for Python, in my kind of general view of this. And so I was looking around, I want to do NLP in Haskell, right? I want to sort of do two cool things, I like, let's say, and I want to sort of survey the field, and I actually don't find many of Haskell libraries for NLP, right? So a lot of them, so you probably can wrap a lot of C libraries, not a lot, but whatever is there, right? But again, computational scientists, linguists are not doing this in C. So it's almost like, you'll be interfacing with Python or JVM, and on JVM, if they wrote it in Java, you can pick it up from Scala Clojure.
That's absolutely right. And that's one of the strongest arguments for Scala.
And I don't foresee anything in Rust or Go, much in this.
Rust isn't gonna have that.
Okay, so the only reason I see you even having this choice is like the practical and pragmatic approach is often you end up writing everything yourself, or a lot of it yourself, right? So if it sounds like you guys are ready to just write a bunch of stuff yourself.
Yeah, our NLP needs aren't that heavy. We've actually we outsource a lot of our NLP to a provider called Alchemy API, which is just some pretty awesome work. for us, it's more the document structure analysis. So there's a little bit of machine learning in there, but because it's kind of an unusual problem that not a lot of people have really put a ton of energy into solving, there aren't a huge amount of libraries available.
Yes.
Machine learning, like classifying elements on documents, that'll be a big thing. But you hit the nail on the head with libraries in Scala, and that is the principal advantage of Scala. And there's what we talked about, like someone should write something like CoffeeScript to translate the Haskell syntax into Scala would be wonderful.
Yeah. So I'm curious about the choices. I mean, I hope once you finalize it and your DocPunch is underway, we'll have you back and you can tell us, what's going on and how you pick that other choice. So thank you very much for coming. I think it was great having you here, and we definitely wish you lots of luck in your new startup adventure. And hope to see you soon. Tell us more about your technology experiences.
Great. Thanks for having me.